What is up everyone, welcome back to our channel Inside Python, and this is second episode of the machine learning series with Python. So now in the previous video we learned about what is machine learning, we set it all up. So now in this video we're going to be moving on to some algorithms. Now the first thing that we're going to learn is called linear regression. We'll talk about it later, but first of all, without wasting any time, let's get the data set. Now also before that, I want you all to follow us on our Instagram page at inside_python. The link will be down in the description, and also subscribe to this YouTube channel for more of such content. So here I'm on a UCI machine learning repository. So it is a very educational repository available for all the data sets, whether it will be regression, some other things like classification, etc, etc. So this is the best thing. So now I will be downloading this data set and we'll be working on this student performance data set. So the link will be down in the description, you can download it from that. So now here is a complete information of this data set. So it is the source, the data set information, that means how did they get this data, and here the associated task, classification, regression, missing values, and etc. Now this is the main thing, the attribute information. Now attributes are basically called columns. If you know about any kind of two-dimensional data, it will be column. So it has the school, the age, address, font size. Now we will not use all these 33 attributes. We'll be only using 5 to 6 data attributes in this. So let me tell you what we're going to be making. We're going to be making a machine learning model that can predict the third grade of the student. So this is the first grade, the second grade, and the third grade. So it can, our model will be able to predict the third grade from the first grade, the second grade, the study time, the absences, the failures, etc, etc. So I have already downloaded this data set. Just click on this data folder and install it. The link will be down in the description. So now let's move on to our PyCharm. So here I'm on my PyCharm. As you can see, I'm using this Python file, and this is our data set. So if I open it, you can see there's a lot of data. I think it is 649 students. The data of 649 students is here. So I think that's good. Basically, okay, I accidentally pressed space, so I have to correct it. So this is the data. Now one thing to notice here, that instead of the delimit, now CSV files generally have the comma separated values, but as you can see here it is semicolon. So we have to set a different separator here while taking the data. So let's just get the data right into our purpose. So now the first thing that you want to import is sklearn. So right here, import sklearn. Now you need to import the pandas module as PD, these are called aliases, and the numpy module as NP. Okay, now from sklearn you need to import the linear model. Okay, it is not okay, I think just it is sklearn. So import linear model. You can see here from sklearn import linear model. So now what we are going to be doing, we are going to be predicting the third grade. But how do we do that? We need to get our data. So right here, data equals to pd.readcsv, pd.readcsv, pandas.readcsv. Now the name of the file, so studentmat.csv, and now since the delimiter is semicolon, so we have to set it. Okay, so right here sep, that's a separator, and write semicolon over here. Okay, so I think it would get our data. So let's just print the head of this data. This function basically means that print out the first 5 rows of our data. So let's try to run it. Control Shift F10. Okay, just wait, it's running. It's a very big data, it might take some time. Just wait. Okay, so we got our data. Here are 5 rows and 33 columns. Okay, 33 attributes we have. So it is a G1, G2, the absences, the wells, P status, and it is all those things. So now to predict the data, we need to define some features. So features are basically the values on which our prediction will depend. Okay, so what are the features here? Okay, now before even that, we need to set this data for our use. Okay, so we don't need all those 33 columns, we only need 6 columns here, and data. So write here data, and then we will take out some values like the G1, and again write here the G2, then again write G3, then we will need in study time, write here study time, and then I think we will be writing absences, okay, and then the failures, okay, the past failures actually. So let's print out the data head of this, print out the data dot head, okay, let's run it again. So as you can see here, let me just, so this was our previous data from the original data frame, and this is our customized data that we will use, the G1, G2, G3, study time, absences, failures. Now talking about the features. So as I said earlier, that features are the values on which our prediction will depend. So what is our prediction basically here? So our prediction would be, so we will write predict, okay, so predict equals to G3, we need to predict the G3. So what are the features on which G3 depend? The G1, G2, the study time, absences, failures. Okay, and talking about label. So label is the value to be predicted, as simple as that. So we need a NumPy array of all the features and a second NumPy array of the label. Okay, so write here x equals to, so x will be our feature array. So write here np.array. And in this you need to write data dot drop. Now we can remove this print statement over here. So data dot drop, and in this you need to write, I think what it would be, data dot drop, okay, predict. So what it will do, it will remove the G3 column from the data set, and it will give all the rest of the columns left. So it will give us G1, G2, study time, absences, failures, but not G3. Okay, that's what we need. This is the feature array. X is the feature. And now talking about the label. So write here np.array, and I think the spelling went wrong. Array data. Now this is simple. You can use the indexing suppose, and write your predict. Okay, so that's simple. So this is the X is feature, Y is label. Okay, so I think this would be good. So now the next thing we're gonna do is we want to split our data into test and train data. So now why we have to split this data? Because you know that computer is very good at learning information. It can just grab, just mug up all the information. So if we give it the data that he has already seen, so it will predict the value which has already seen, not a new value. It will not be a prediction. So we have to split our data. So how do we do that? So write here x train, comma x split. Okay, not, it was x test. X train x train x test, y train, and y test. Okay. Now again I am saying x are the features, y are the labels, even in the test and split data. So in this you need to write sklearn dot model selection dot test train split, train test split, basically train underscore test underscore split. Now it will have two arrays. One will be of the features and the second one will be of labels. So it is like position oriented. So first we need to specify our array with all the features and then the array with label. Okay, so x comma y, and then we have one more attribute to specify over here, that is the test size. So we will write test size equals to 0.1. So this means that our test size will be the 10% of the original data. You can modify this, but I'm writing 10%. I need only 10% of the data for testing. Okay, and 90% of the data will be used for training. So why we did that? I already told you that computer is very good at learning information. So once we train it, so again we give the data that is already seen in the test data. So it will not predict anything. It will just return the result it has already learned. There will be no prediction. So if I'm correct, this code will not produce any kind of error. So let me just run it. Okay, so it is writing method object is not subscriptable. Okay, so now what is the problem here? We need to specify this predict in parenthesis, and then we need to specify also one thing, that is 1. Now if we write 0 over here, this is called the axis. If we specify 0 over here, so it will bring out a row, but we need a column. Okay, so let's try to run it. I suppose it will not run into any error. So process was finished with exit code 0, means we got literally no error, so we're good to go. So I think I would be seeing you guys in the next video. So in the next video we're going to be learning about what is linear regression basically and how it works, and then we will go on further to create our model, and also follow us on our Instagram page. The link is down in the description, and don't forget to hit that red subscribe button. And thanks for watching our video.